Around the world today we have 7 species of turtles still remaining, and they're divided up into 2 families of turtles. There's what we call the leatherback turtles. They don't have the hard bony shell on the outside, and we have what we call the hard shell turtles, the more conventional turtle with that hard shell and big scales. And within the Pacific basin we have 6 of the world's 7 species, and the flatback turtle, which occurs only in the Australian continental shelf, doesn't go outside into the oceanic water. Let's start with an animal that's in the coastal waters, say living in Moreton Bay or living out on the rocky reefs off from here. Around about this time of the year, the breeding adults are migrating to wherever they go to breed. So for the green and loggerhead turtles in this part of the world, they go primarily into the southern Great Barrier Reef, Sandy Cape area for their courtship, and they aggregate for the courtship, and there's about a month of courtship activity. At the end of that, the males go home and the females then move to their nesting beaches. That could be a move of maybe tens of kilometres to about 250 kilometres or so, and they then sit offshore from the nesting beach, and the female then comes up and lays a clutch of eggs on the beach, and she then goes back and sits offshore to make another clutch of eggs, and she does that repeatedly through the season and lays several clutches of eggs. And then at the end of the nesting season she goes back home. When we say go back home, they go back to where they started from for that migration. So if the turtle was living in Moreton Bay and swam up to, say, Northwest Island to lay its eggs, it comes back to Moreton Bay. If it was a turtle living in the northern Great Barrier Reef, say Princess Charlotte Bay, and it swam down to lay its eggs at Northwest Island at the end of nesting, it goes back to Princess Charlotte Bay. So they've got quite specific locations that they migrate backwards and forwards. The eggs incubate in the warmth of the sand, no parental care. The sex is determined by the temperature of the nest, and then the bubs go out into the open ocean and they get carried by the ocean currents, and they spend a period of time from 5 to about 15-20 years out in the open ocean, and they then move back into coastal waters and take up a residency in an area that they'll eventually grow up and be adults in that location. Now that whole cycle from an egg through that oceanic phase, growing up in coastal waters to make that first breeding migration, depending on the species, is somewhere around that 30 to 40 years when they first start breeding. Okay? No breeding until you get that old. And then they don't breed every year, and depending on the species they might come back and breed every couple of years. They may be taking 6-7 years or so between breeding seasons. So very slow to replace if the population is reduced, because it takes so long for the next generation to be available for breeding, and once they're adults they don't breed all that regularly. It means that these are a group of animals that makes them very susceptible to problems of increased mortality. If we look at the different species of turtles, we find that they don't just nest anywhere. If we look at loggerhead turtles for the Pacific, there is no loggerhead nesting on the other side of the Pacific in the Americas. All the loggerhead nesting for the Pacific occurs over here in the east, either in Japan or here in Eastern Australia, and just a very small amount out in New Caledonia and the bottom end of Vanuatu. So we can be pretty confident that loggerheads that are being caught out in the mid-Pacific are coming from one of those 2 areas. There's other loggerheads that nest in the Indian Ocean, but there's no tag recoveries to indicate that the Indian Ocean turtles come over our side into the Pacific at all. Now, for green turtles, they're a much more abundant turtle than the loggerheads. And if we have a look at their nesting in Eastern Australia, you can see there's a lot of nesting up here in the north, there's a lot of nesting down in the south, out in the Coral Sea and so on. And from the work that's been done looking at the genetics of these animals, you can actually look at the DNA in the cells of the turtle, and we're able to identify via a lineage of, we call it female inheritance. We can basically look at the mother, the grandmother and whatever, and identify the extent to which these groups of turtles are interbreeding. And what we find is that there is a grouping of the turtles that nest in these different areas, that the green turtles nesting in the northern Great Barrier Reef interbreed with each other, but they do not interbreed with the green turtles that nest in the southern Great Barrier Reef, or with the green turtles that nest out here in the Coral Sea, or with the ones over there. So what we're seeing here then is genetically a way to identify where was this animal born. So if you caught it away from the nesting area, using the genetics you'd be able to identify, well, this is a turtle which originates from the northern Great Barrier Reef or from the southern Great Barrier Reef. One of the things that we've learned out of this is that when a turtle breeds, it goes back to the area where it's born. So irrespective of where it travels, a green turtle that was born in the southern Great Barrier Reef, it may have gone way out past Fiji at some stage in its life, but when it becomes an adult and it comes time for it to breed, it will come back to breed in the southern Great Barrier Reef. It's not going to go and breed in the Gulf of Carpentaria or over in Western Australia or up in Hawaii or somewhere like that. Now, some of the basic tools that we use in our research to gain this sort of information, one of the obvious and very visible tools we use is tagging, and you'll see them later. We have a titanium tag. Titanium has been chosen because it's totally non-corrosive in seawater, and it can be attached to the back edge of the flipper of a turtle. It carries a number so that we can recognise it as an individual, and we have lots of information that come from the tagging, both with us going out and catching the same animal across the years, or with members of the public finding a turtle, be it a fisherman or a indigenous hunter or whatever, finding a turtle with a tag on and telling us about where they found it, what it was doing when they found it and so on. And so we can learn a great deal about the movements and the longevity and the reproduction and so on of these animals. From the tag recoveries, this is an example for our green turtles. Tagging on the nesting beaches in the northern Great Barrier Reef, these lines represent endpoints for where a green turtle has migrated from to come and nest on the beaches there. And you can see that if you tag a turtle on a beach, it could come from up here in Irian Jaya, out in Western Arnhem Land, through the Gulf of Carpentaria, southern New Guinea, what's this one, probably Vanuatu, New Caledonia, or anywhere along the east coast. And so you've got turtles from all over the place coming in to lay eggs and then going back out at the end of the nesting. And on the other hand, a turtle which lives up in here in eastern Indonesia, yep, it may be a turtle that nests in the Barrier Reef, but it could just as easily be a turtle that nests in Western Australia, or it could be a turtle that nests over in Borneo. So they're migrating from widely scattered feeding areas to each of the breeding locations. Now this is all migration of adults, and typically if you draw a line about 2,500 kilometres radius around where they nest, that's where you can expect them to come from. When they get to the nesting beach and they lay their eggs, if the eggs aren't laid above the high tide mark, they won't hatch. And so they've got to come up high on the beaches. The eggs incubate in the warmth of the sand. The female, as I said before, makes a run up the beach about every 2 weeks. So if we follow this particular lady, Monrepo Rookery's up near Bundaberg, She comes up on the 21st of November, she lays 124 eggs, and she goes back and sits offshore for 2 weeks. 13 nights later, she comes back and lays another 133 eggs. Now remember I said she's carrying this sperm bank. She doesn't need to go find another mate from that clutch to this, because she's already got the sperm. She's not going to waste energy, resources going out searching for a mate. She just sits offshore and releases the next lots of follicles, fertilises it from the sperm bank, and then comes back. It takes 2 weeks approximately to make a clutch of eggs, and so every couple of weeks she's coming up and laying a clutch of eggs. Because she's got sperm from multiple males, it means that you've got one mum but several dads represented in each one of these clutches of eggs, and giving you that genetic diversity into the offspring. This is what people have seen with turtles over the years, and they've got the impression these animals lay vast numbers of eggs, so therefore there shouldn't be a problem with their conservation. But let's have a look at the history of this particular. This is one that we have been following for a number of years. She actually began her breeding life back in 1989, when she had her first ever breeding season, and she measured 103 centimetres. She laid 6 clutches of eggs that season. Now we didn't see her for another 5 years, and then she returned. She's grown about half a centimetre. She laid 7 clutches of eggs. We then didn't see her for another 4 years, and she comes back. She's grown another couple of millimetres. She lays another 7 clutches of eggs, and then we don't see her for another 3 years, and she came back having grown a couple of millimetres, and she's laid another 8 clutches of eggs. Yes, in one season they lay a lot of eggs, but they don't nest every year, and when you average the number of eggs across the years, their egg production is really quite modest. You'll notice that as an adult turtle, its growth is very, very slow. We're talking millimetres a year across the decades of an adult life. On average, they probably only breed for about 15 to 20 years in their life. We are looking for this turtle now. We very rarely have them nest at 2-year intervals, and so we're looking for this turtle to come back in 2004 and have another breeding season. Now, no one has ever followed individual turtles for this length of time outside of our program. So we're actually generating whole new information. What happens when they get old? Do they become geriatric and sort of slow down their reproduction? Or do they maintain a big egg production for as long as they live? I mean, they're some of the sorts of questions that we're starting to answer out of this. And in fact, what's happening here is that the older this turtle is getting, in fact, the more eggs it's producing, rather than a young turtle being highly productive. But when it gets real old, what happens? There's no parental care. The eggs incubate in the warmth of the sand, and it's the sun-warm sand that controls 3 critical things. How fast the eggs incubate, so do they hatch in 6.5 weeks or do they hatch in 10 weeks? The warmer the sand, the faster they incubate. Typically it's about 8 weeks of incubation. Incubation success: if the sand's below 25 degrees, they won't hatch. If you went and dig a hole in the beaches down Newcastle Way, the sand never gets above 25 degrees in the peak of the summer. So a turtle eggs laid down in Newcastle will just never hatch. When you get up here to the Sunshine Coast, the temperatures are around about 26 degrees at the peak of the summer, so they'll hatch. When you get up into places like the Gulf of Carpentaria, if you went to a place like Bountiful Island, in the peak of the summer the eggs won't hatch, it's too hot. And so up there, the peak nesting of the turtles is actually during winter, when the sand temperatures are cooler, rather than in the peak of the heat of the summer. And then finally, the sex ratio of the hatchlings is a function of the temperature of the nest. Okay, the hatchlings, when they come out of the eggs, there's no parental care. They've got to dig their way to the surface, and Mum put the eggs about 50 centimetres below the surface. And so these little hatchlings have got to dig their way to the surface. It's going to take them 2 to 5 days, typically, to dig to the surface. There's no food and there's no water for them to drink. They are living actually off the last of the yolk that they take in from while they're in the egg, and that's internalised, and they're actually living off an internal food store that carries them through those days of digging to the surface. While they're digging to the surface, and as they emerge from the nest to run across the beach, they're actually learning things. They're being imprinted to the Earth's magnetic field. It's a series of lines of equal strength and equal dip that works just like our lat-long grid on a map. But the turtle learns that, and as far as we can tell, this is the critical information that allows it to know where it is as it travels through space and time on the Earth's surface, and is able to find its way back to the general area of where it's born. It doesn't come back to the exact beach, but at least to get back into the right general area of where it was born. They also respond to light horizons, there's an indication that they may in fact be able to remember the smell of the first water that they contact. So some fairly complex things going on with these little hatchlings as they come out of the nest. They function almost, to our minds, like little clockwork toys when they're running across the beach, but in reality they're learning lots of new information which they carry with them. As they run across the beach, they don't stop to feed, they don't stop to sleep. And in fact, as they go into the sea, exactly the same thing. They just go non-stop. We talk about a swimming frenzy, and these little turtles will swim non-stop for about the first 3 days. They're not stopping to feed, they're not stopping to rest, it's just swim, and away they go. And in a non-stop swim for about 3 days, it normally means they'll get somewhere in excess of 50 kilometres off the coast. And at that point in time, they will cease this swimming frenzy, and they will just simply float near the surface, fold their flippers up on their backs, and they will start within a day or two testing to see what's out there to eat. And they are attracted typically to anything that moves in front of them. So a little bit of jellyfish, try it. Blue bottle, try it. Floating dead fish, try it. Piece of floating plastic, try it. A floating tar ball, try it. And they will eat virtually anything that they encounter as they are floating there. But of course the sea is not a static environment, and you've got your ocean currents, and so they're floating but being transported in that surface drift. And on the East Australian coast, of course, it's the East Australian current. And so a little turtle gets born off the southern end of the Barrier Reef, and within a month or two it's travelled way down off northern New South Wales, and eventually is going to get swept out past Lord Howe Island, out north of New Zealand and out into the Pacific. This leads us then to this stage in the life history of the turtle that for turtle biologists has been called the lost years. It's easy enough for me to get in a tinny and go for a run out into Moreton Bay, or go out to the reefs around Heron Island or something and catch big turtles and study them. How the hell do I follow this little turtle which is, starts off in the Southern Barrier Reef and drifts way the heck out into the Pacific? And so this has been one of the real black holes of understanding turtle biology. These turtles that are out beyond the continental shelf, out in that oceanic environment. They're in surface waters. They probably don't dive all that deeply in those early years. We're talking little turtles the size of a teacup, size of a saucer, a bread and butter plate. Okay, those little tiny turtles. They're feeding on the plankton near the surface, and they spend a period of time out there before they come back to coastal waters. So if we go out into Moreton Bay, we won't see a green turtle less than about 40 centimetres in carapace length. From hatchling to 40 centimetres, they're out over the horizon. That applies through all of our coastal waters. Our loggerheads, though, we don't see them until they're about 80 centimetres in carapace length. So they're growing to a much bigger size before they come back in to coastal waters. When they get into our coastal waters, we've got a lot of information on their growth and movements and so on, and they're slow growing. We're talking about animals that are about, for a loggerhead, it's about 30 years old when it breeds for the first time in its life. Our greens are about 40 years old when they breed for the first time in their life. Very, very slow growing, and decades old at that first breed. You've heard the idea that, you know, very few baby turtles become adults, the idea that 1 in 1,000 makes it to adulthood. Unfortunately, people have assumed that that's because they all die as little ones, and then somehow or other no more die until they become adults. And that's not really the way it works. If you take 30 years to grow up and you start 1,000 youngsters off, and you have, say, 10% die in a year, which was a very high survivorship for a little turtle, at the end of 1 year you've got about 900. At the end of 2 years you're down to about, if you're losing 10% per year, you're down to about 810. At the end of 3 years you're down to 700 and something. At the end of 4 years you're down to 600 and something. By the time you get out to 30 years there is practically nothing left, not because they all died at the beginning, but you lose a small proportion every year for 30 years. You've got to have a high survivorship in any 1 year, just so some make it to maturity. And this is the crux of understanding the impact of the human-induced mortalities that we bring to bear on these species. That it's absolutely critical that there is a high survivorship per year for these animals, because if it isn't there, if it's extended across the years, they're very susceptible to those impacts. The natural mortalities out there, basically anything that's got a mouth big enough. So if you're a little turtle the size of a matchbox, there's a heck of a lot of things potentially could eat you. But there's fewer of them out in the open ocean than in the coastal waters up against the coast. And so the life history strategy for the turtles is to get them away from the coastal waters, get them out in the open sea where there are fewer predators that they're exposed to. As they get bigger, it's reducing down the number of things that potentially can eat them. But even the largest turtle, there's crocodiles, tiger sharks, killer whales and so on that can still eat even the largest turtles that are out there in the sea. There's diseases and all those natural events that can be part of that low mortality per year that has to be there if the species is going to survive. Different sized turtles leave the open ocean at different sizes. Here in Eastern Australia, our hawksbills leave at quite small size, about 36 centimetres. Our greens are coming out at about 44 centimetres, and our loggerheads are coming out close to 80 centimetres in carapace length. Now that's the size at which they leave the open ocean and come back to coastal waters. The age for these, our hawksbills are about 5-year-old when they come out. Our greens are somewhere in the 5 to 10-year-old, and our loggerheads, well, it's a bit shaky on the side of the age, but somewhere in that 15 to 20-year-old when they come out of the open ocean to reside in our coastal waters. So different species, different open ocean exposure. If we add in the leatherbacks, I haven't talked much about leatherbacks, but they don't live in our coastal waters, or if they do, it's just a temporary come in, and they continue to feed on plankton at the surface. So they're really totally pelagic, totally oceanic in their life, quite different to the other species. And really, from a longline fishery perspective, it's going to be the longer the turtle is exposed to the risk of being caught, the greater is going to be the threat. So in terms of looking at our turtles and the interaction with longline fisheries, the two species that have the greatest problems are the ones that spend the longest time. Leatherbacks spend their whole life out there, and loggerheads are spending that 15 to 20 years. So you'll find that in the discussions about the significance of long-line impacts on species, those two species will keep cropping up as the significant ones, is because they're the ones that are spending that long exposure to the problems. And before long-line fisheries, of course, the high seas gillnet fisheries were interacting with the same groups of animals.